25 May, June, paper 24. Let's take a look at the question number 1A. Find the values of K for which the systems of the equations over here does not have a unique solution. So in order for a systems of equation does not have unique solution, that means the determinant must be a 0. So we just write down the coefficient of the x, y, z. And then let it equal to 0. So we just need to do the multiplications to find the determinant properly. 45 minus 12k minus a 2 of a 9k minus a 42 plus the 3 of a 2k square minus a 35 equal to 0. So we just need to expand and simplify. You will get 6k square minus a 30k plus the 24 equal to 0. They all multiple of 6. Divide everyone by 6. Then you can factorize it to get k minus 4, k minus 1 equal to 0. So your k is equal to the 1 and k is equal to 4. Done. This will be the number 1A. Move on, we have a B. Given that the k is a 1, show that the systems of equations in part A is consistent and interpret the situations geometrically. So we need to replace the k become 1 over here. That means all these become 1. So you will get x plus the 2y plus the 3z equal to 1. X plus the 5y plus the 6z is equal to 1. And 7x plus the 2y plus the 9 z is equal, or this one is 2. This one is 3. So from here we can make it become the augmented matrix form. And it will look like this. So we just need to apply the row operations. Take the R2 minus the R1, take the R3 minus the 7R1. The row number 1 just remain. The row number 2 now it will become 0, 3, 3, and 1. And then the row number 3 will become 0, negative 12, negative 12, and negative 4. Divide the row number 3 by negative 4. Then you get the row number 1 and 2 just copy down. Then this one it will become 3, 3, 1. So you can see that now the row number 2 and row number 3 are the same. Just take the row number 3 minus the row number 2. You will get the last row all 0. And the row number 1 and row number 2 just copy down. Okay, so from here we can see that this will have infinite solutions. Therefore is consistent. Okay, then we need to interpret the result geometrically. So we just say that the 3 planes form a sheaf. Okay, that's all. So this is the answer for the number 1B. Move on. We have a question number 2. For the integrations over here, giving your answer correct to giving your answer in logarithm form. Okay, so we need to integrate this from 1 until 5 over 2, 1 over the square root of the x squared minus the 2x plus 5. So this trick is quite common. We just need to do completing the square for the denominator over here. Then you will get x minus 1 square plus 4 dx. So from the formula booklet, actually we can just integrate them directly. Okay, so this will be arcsine of x minus 1 over 2. Just need to replace the 1 and 5 over 2 inside. Then you will get arcsine of 3 over 4 minus the arcsine of 0. So arcsine of 3 over 4 also refer to the formula booklet, MF19. You look for the logarithmic form of the inverse hyperbolic functions. It will be x plus the square root of the x square plus 1 minus a 0. So just simplify them. You will get this one as the 3 over 4 plus the 5 over 4. So at the end, you get ln 2. Done. This will be the answer for the question number 2. Move on. We have question number 3. We are having a curve. The curve has a parametric equation as given here. And they want you to show that 1 is the only real value for t where the x equal to 0. So when x equal to 0, you have a t cubed minus a t squared plus a t minus 1 is equal to 0. So we can actually factorize this one out. Then I factorize the t minus 1 out again. I get the t squared plus 1 equal to 0. I get the t equal to 1 and the t squared plus 1 equal to 0. So this is the solutions. This one is no real solutions. Okay, so rejected. Rejected. So therefore, t equal to 1 is the only real value. Real root. Real solutions for x equal to 0 shown. So that is the answer for A. Then B, we want to find the dy dx. So your x is t cubed minus a t squared plus the t minus 1. Your y is equal to the t e power t. So your dx dt is a 3t squared minus a 2t plus 1. Your dy dt is keep the left, differentiate the right, plus keep the right, differentiate the left. So your dy dx is equal to the dy dt divided by the dx dt. So you will be having this one we can simplify it, factorize it. So you will get t plus 1 e power t divided by the 3t squared minus a 2t plus 1. So done, shown. Okay, so this is the answer for the question number 4b. Moving on, we have a 4c. Find the Maclaurin series for y up to and including the terms of x squared. Okay, so our y, that means we need to find the d square y ds square. Okay, d square y ds square. Okay, so over here, your just now we have found that the y is, just now the question giving you this, then your dy dx is actually t plus 1 e to the power of t over the 3d square minus the 2d plus 1. So now to find the d square y ds square, we need to do the chain rule. That means we break this one become d dt of the d plus 1 e power d divided by 3d square minus a 2d plus 1 multiplied by the dt dx. So what you need to do is keep the bottom, differentiate the top. Differentiate the top, you get this. Minus keep the top, differentiate the bottom. This one, it will be 60 minus a 2 divided by the 3d square minus a 2d plus 1 square. But this one is actually 1 over the 3d square minus 2d plus 1. So I have to multiply this with the 3d square minus a 2d plus 1. Okay, not enough space, so I just squeeze everything inside the denominator here. So you can see now the denominator is actually, the power has become 3. So I think I just need to expand, factorize this one out, e power d out, so that I can get 3d square minus 2d plus 1 multiplied by d plus 2 minus the this one. If you factorize it, you will get d plus 1 and 6d minus 2 divided by the 3d square minus a 2d plus 1 cube. So over here I have a 6d square. 6d square plus 4d minus 2. This one I expand. Make it become 6d square plus 4d minus 2. Okay, that is your dy, d square y, ds square. Okay. Then when x equal to 0, your d is equal to 1. So your y, that means over here is in terms of d. Okay, because from the equations that we have here, all is in terms of d, but we need to have in terms of x, because when I put the substitute 0 inside, actually this is the x equal to 0, but x equal to 0, d is equal to 1. So over here, this is a little bit different than usual. So we need to replace the d as a 1. Okay, so the y1, it will be 1 e power 1, it will be e. And then the y prime 0, maybe we call it y prime 0. Y prime 0, but it's actually, this is x is a 0. Then when you use d, the d has to be a 1. So you're supposed to put 1 inside. So it will be 1 plus 1 e power 1 divided by 3 minus 2 plus 1. So you will get this one as the e as well. Then the y double prime 1. Again, you're supposed to put x equal to 0, but the d is a 1. So you need to change this become 1. So when you put a 1 inside here, that means it will be, that means you just need to use this result, change the d become 1. So you will get e. You have a 3 minus 2 plus 1, 3 minus a 6 plus 4 minus 2 divided by the 3 minus 2 plus 1 cube. So if you solve it, you're supposed to get this one as a negative 1 over 4e. Okay. Then, therefore, your function, okay, your y is equal to the y1 plus the y prime 1 x plus the y double prime 1 of the x square over 2 factorial plus a dot dot dot. So just replace the value. You will get this as a e plus ex minus a 1 over 8 e power x square plus a dot dot dot. Okay, done. This will be the answer. Okay, so this is the answer for the number 4C. Moving on, we have question number 5. Over here, second order differential equations, we want to find the particular solutions for the second order differential equations over here. So we, first of all, we take the left-hand side out. Plus a 5y equal to 0, let it equal to 0. Then we convert them to become auxiliary equations, AE. You get m squared plus 4m plus 5 equal to 0. Solve the quadratic equations by using the quadratic formula, negative b plus minus of the b square minus the 4ac divided by 2a. Then you get this one as a negative 2 plus minus I. Okay, so your complementary functions, yc, will be equal to the e to the power of negative 2x, a cos x plus the b sine x. Okay, that is a complementary functions. Now we want to go for the particular integrals. Yp, your right hand side is an exponential function, so I call it b e power 3x. Then from here you will get the y prime and the y double prime. So you just replace them inside the differential equations. Y double prime plus 4y prime plus 5y will equal to the 13e power 3x. So just substitute accordingly. You will get this one as a 9b plus the 12b plus the 5b e power 3x is equal to the 13e power 3x. So you will get this one as the 26b is equal to 13. That means the b is a half. So therefore, your y is equal to the yc plus yp. That will be equal to the e power negative 2x, a cos x plus the b sine x plus the half e power of 3x. That will be your general solutions. And we need to find the particular solutions for the constant a and b. So what we need to do is we need to differentiate. Maybe we can find the a first. When x is equal to 0, your y given here is a 1. So you will be having the y is a 1. So you get 1 is equals to the e power 0, a plus a 0 plus a half. That will give you a is equals to the half. Okay, then your dy dx, keep the left, differentiate the right. Plus keep the right, differentiate the left. This one not enough space. Let me try to squeeze everything inside here. A cos x plus the b sine x plus the 3 over 2 e power 3x. So when the x is equal to 0, your dy dx is a 0. So you'll be having 0 equals to the e power 0, 0 plus b minus a 2, a plus a 0 plus the 3 over 2. So you will get b minus 2a is equal to the 3 over 2. Since the a is a half, a is a half. This is a plus. Okay, since the a is a half, that means the b will be equals to the negative half. So therefore, your final answer, your y will be equal to the e power negative 2x, a cos x, plus the b sine x, plus the half e power 3x. Done. So this answer will be your particular solutions for the second order differential equations over here. Done. So now we move on to the question number 4. Question number 5a, use the De Moivre theorem to show that this relationship is true. So what you need to do is first of all, we let cos theta plus I sine theta is equal to C plus IS. This is quite routine. We just need to power the 7 for both sides. Left-hand side, use the De Moivre theorem. The right-hand side, just use the binomial expansion. C power 7 plus the 7C6 IS plus the 21C4 IS square plus the 35C cube IS, this is a 5. This is a 4. This is a cube. Then plus a 35C3 IS power 4 plus the 21C square IS power 5 plus the 7C IS power 6 and finally plus the IS power 7. So if you expand simplify, you will get the real part will be like this. This is the real part. Plus the imaginary part, it will be 7C power 6S minus the 35C power 4 S cube. Then plus the 21C square S power 5. Then minus the S to the power of 7. Okay, so by right, this is what we have. So we are looking for the sign. Cos 7 theta is not in our concern, so we only consider the imaginary part. Take the imaginary part, then you will get sine 7 theta is equals to the 7C power 6S minus the 35C power 4 S cube plus the 21 S C square S power 5 minus the S to the power of 7. So given that the C square plus S square is equal to 1, that means the C square can be written as 1 minus S square. So your sine 7 theta is equal to the 7 of the C square cube minus a 35 of the 1 minus S square plus the 21 of 1 minus s squared s power 5 minus the s power 7. So we just need to expand them carefully. So you get 7s. So you get 1 plus the 3s minus the 3s. This one is a square. Plus the 3s power 4 minus the s power 6. So this one you get negative 35 s cubed. S power 4 minus the 2s squared plus 1. This one you will get 21s power 5 minus the 21s power 7 minus the s power 7. Expand all together and then combine all the s power 7 you combine together. You get a negative 7 minus the 35 minus the 21 minus the 1 s power 7 plus the 21 plus 70 plus 21 of s power 3 power 5. Then plus a negative 21 minus a 35 s power 3 and plus the 7s. Okay, simplify them. You get negative 64 s power 7 plus 112 s power 5 minus the 56 s cubed plus the 7s. Therefore, sine 7 theta is equal to the negative 64 sine power 7 theta minus the 112 sine power 5 theta minus the 56 sine cube theta plus the 7 sine theta. Shown. So this is the answer for the question number 5A. Done. Then number 5B. So number 5B, we actually need to use the result in part A and to figure out how to solve it. So for part A, you can see that just now the power is a power 7, but this one the power is power 6. Okay, and you can see that the coefficient here are the same. Only the positive and negative sign are different. Okay, so but what we need is a power 7. So what we need over here is that we just need to multiply x. So you get 64x power 7 minus the 112x power 5 plus the 56x square x cubed minus the 7x is equal to the 0. So we let our x is equals to the sine theta. So you get 64 sine power 7 theta minus the 112 sine power 5 theta plus the 56 sine squared theta minus the 7 sine theta equal to 0. So it will be negative sine 7 theta equal to 0. That means your sine 7 theta is equal to 0. So your formula, general formula for the sine 7 theta is the n pi plus the negative 1 power n of alpha. Okay, so actually this one no need because the alpha is a 0. So this is actually the same as a sine 0. So it's n pi, your n is equal to the 0 plus minus 1 plus minus 2 and plus minus 3. Okay. So your 7 theta will be equals to the 0 plus minus pi plus minus 2 pi and plus minus 3 pi. So your theta is equal to the 0 plus minus 1 over 7 pi plus minus 2 over 7 pi plus minus 3 over 7 pi. Okay. Now the tricky part is over here. Your x equal to the sine 0 had to be rejected. Because just now we multiply everyone by x. Okay, that means originally it's supposed to be this multiplied by x. So that means you get x equal to 0 and another one is x equal to the 64 x power 6 minus the 112 x power 4 and so on equal to 0. So this x equal to 0 is not belong to here. Okay, so the x equal to 0 is supposed to be rejected. So therefore your x can only be sine plus minus the pi over 7. So we just sine pi over 7, sine negative pi over 7, sine 2 pi over 7, sine negative 2 pi over 7, sine 3 pi over 7, and the sine negative 3 pi over 7. Okay, so this is the answer for the question number 5B. Done. Okay, so now we move on to the question number 6. All the differential equations over here giving as the following, and they give you that when x equal to 1, y equal to the half pi, they want you to find the answer of y in terms of functions of x. So what we need to do is that we will divide everyone by the x, because we know that this one can be solved by using the integrating factor. So your IF integrating factor is e to the power of integrate negative 1 over x dx. That will give you e negative ln x. That will give you e power ln of 1 over x. It will be 1 over x. So this is your IF. You multiply the IF. So you will get 1 over x. dy dx is minus the 1 over x squared. Is equal to the 2 uptangent of x. So this can combine together. D dx of y over x is equal to the 2 uptangent of x. So that means integrate dy over x is the same as integrate 2 uptangent of x dx. So your left hand side you will get y over x, and your right hand side had to use integration by part. You get 2x uptangent of x minus the 2x over the 1 plus x squared dx. So continue to integrate. You will get your left hand side, right hand side as a minus a ln of the fx plus a c. Given when x equal to 1, your y is equal to the pi over 2. So you have a pi over 2 is equal to the 2 uptangent of 1 minus a ln 2 plus a c. So you will get c is equal to the ln 2 plus the pi over 2 minus the pi over 2 is equal to the ln 2. This one can cancel. So therefore, your y is equal to the 2x squared uptangent of x minus the x ln 1 plus x squared and then plus the x ln 2. Or we can simplify further by combining the ln together you will get plus the x ln of 2 over 1 plus x squared. That will be the answer for the question number 6. Done. Moving on, we have a question number 7. A given as the following matrix over here, we want to find the matrix B and the diagonal matrix D such that the A power 6 is equal to the BDB inverse. So what you need to do is to find the eigenvalue. So the eigenvalue is actually, because the lower triangle here is all 0. So your diagonal over here, they are all the eigenvalues. It will be lambda equal to the 1, 2, and negative 3. Okay. So we need to find the eigenvector when the lambda 1 is equal to 1. So you will be having, make a matrix become 1 minus lambda, 2 minus lambda, 3 minus lambda. This is a 7, 11, and 5. So when you change the lambda become 1, then you will get this as a 0, 0, 0, 1, 0, 2. This is a 7 and 11. I take the first two rows to do the cross product. So it will be 0, 7, 11, and 0, 1, 5. So if you do the cross product, you will get 24i plus the 0j plus the 0k. Take the 24 out, you can get 100. This will be your E1. Eigenvector number 1. Now for eigenvalue number 2, which is a 2. Again, we had to choose 2 suitable vector to do the cross product. So this time when you put 2 inside, this will become a negative 1. This one will become a 1. This one will become a 0. So we choose the first two, negative 1, 7, 11, and 0, 0, 5. So do the cross product, you get 35i plus the 5j plus the 0k. Then you will get this one, take the 5 out, you get a 710. So that means your eigenvector number 2 will be taken as 710. Same thing happened when the lambda is equals to the negative 3. So again, we just need to take 2 suitable vector. So if you put the lambda equals to the negative 3 over here, so you will get, this is a negative 3 here. Lambda negative 3. Then you will get a 4. You will get a 5. You will get a 0. So we need to take the first two rows, 4, 7, 11. And 0, 0, 0, 5, 5. So we do the cross product, you get negative 20i minus a 20j plus the 20k. Take the negative 20 out. You get 1, 1, negative 1. So that means your eigenvector number 3 will be the 1, 1, negative 1. So therefore, your P will be equal to the eigenvector number 1, eigenvector number 2, and eigenvector number 3. And your D is equals to the diagonal matrix of power 6. The diagonal matrix power 6 is the eigenvalue here. Power 6. So you get 164 and 729. Done. This is the answer for the number 7A. Moving on, we have a 7B. we want to use the characteristic equations to show this. So for the characteristic equations, we just need to take the lambda. Just now the root for the lambda is a 1, 2, and -3. Expand them carefully one by one. You get this one as a lambda square minus 3 lambda plus 2. So expand it again, you get a lambda cube minus a 3 lambda square plus the 2 lambda plus the 3 lambda square minus a 9 lambda plus 6 equal to 0. This one can cancel. So you get lambda cube minus the 7 lambda plus 6 equal to 0. This is the characteristic equations. And from the Cayley-Hamilton theorem, we get a cube minus a 7a plus a 6i is equal to 0. So your a cube is equal to the 7a minus the 6i. And to get a power 6 is the a cube multiply a cube. So it's a 7a minus a 6i and a 7a minus a 6i. So you square it, you get 49a squared minus the 84a plus the 36i squared. So therefore your a power 6, by right, this one is ai. Okay, it's ai. Then you can simplify further, become 49a squared minus the 84a plus the 36i. Done. This will be the answer for number 7b. And move on, we have question number 8. Zero. Sketch C and state the equations of the asymptote. Okay. So we need to write down the y equals to the tanh x in the exponential form. It will be e to the power of x plus the e to the power of negative x divided by e to the power of x. This is above is negative, below is positive. Then the asymptote will be the limit that is approaching to infinity. And this will give you y equal to 1. That is your horizontal asymptote. Okay, so that means when we sketch a graph, we need to know that, we need to show that the horizontal asymptote over here, this is the 1, and it starts from 0. This is the x, this is the y, and your graph will be like this. Okay, so this is the graph for the number 8a. Done. Y equal to the tanh x. So now we move on to the B. By considering the suitable set of egg rectangles with a unit width, use your sketch to show that the sum of the series of tanh r equal to 1 until n is greater than ln cosh n. So what we need to do over here is, first of all, we let the tanh x as a function of fx. Okay, so from the diagram that we have over here, you can see that this is a unit width, 1 unit, 2 unit, 3 unit, and so on until n minus 1 and until n. So from here, you will build the rectangle until the last rectangle is over here. Okay, so these are the situations. So what you need to do now is to multiply f1 multiplied by 1 plus the f2 multiplied by 1 plus until fn multiply 1 is greater than the integrations of the tanh x dx from 0 until n. So over here, your left-hand side can be written as fr, where the r equals to 1 until n. The right-hand side, you can just integrate them. If you integrate them, you will get ln cos from 0 until n. So this one, the left-hand side can write as tan r greater than the ln cos n minus a ln cos 0. So we all know cos 0 is a 1. So that means you're able to show the result is greater than ln cos uppercase n shown. So this is the answer for the B. Now we move on to the C. The arc C joining the point x equal to 0 and x equal to the half ln 3 is rotated through one complete revolutions about x. The area of the surface generated is denoted by S. Use a substitution u equal to the square root of 1 plus sec power 4x to show that the S can be written in such a form. So what you need to do over here is that we need to know that the formula for the surface area is a 2 pi y square root of the 1 plus the dy dx square. Okay, so this is what you need to know at the very beginning, and from 0 to the half ln 3. So that means at first we need to find the dy dx. Okay, so we shouldn't start from here, this over here first. We should start from the dy dx. So your tan x, if you differentiate, you get sec square x. Okay, then the square root of 1 plus the dy dx square is actually square root of the 1 plus sec power 4x. Okay, then your s is equal to the 2 pi y square root of 1 plus the dy dx square dx 0 to the half ln 3. So we just need to change this y become tan x, and this will become 1 plus the sec to the power of 4x dx. So this is just the beginning. Then we need to use the substitutions. We let the u equal to the square root of 1 plus the sec to the power of 4x, make it become the u squared. Okay, then we do the implicit differentiations. 2u du dx is equal to the 4 sec power 3 x negative sec x tan x. So you will get this as the negative 4 sec power 4x tan x. Okay, so this will be 2u du dx. Okay, so what you can do over here is that we are ready to replace this to become the u, but we have how to settle this. It's a problem. So what you need to do over here is from here, we actually can get that the sec power 4x is a u square minus 1. Okay, and then we can bring it over here. become the 2u du over the 4 sec power 4x is equal to the negative tanh x dx. Or maybe we just write the negative, we also leave it here. There's a negative here. So for this reason, we will change the sec power 4x over here to become negative u over the u square minus 1 du is equal to the tanh x dx. So we need to get this one ready. Okay. But however, we still cannot substitute yet because we still need to set the value. When the x is equal to 0, your u will be the, you need to replace x equal to 0 into the sec 0. So this one is x equal to the 0, your u is equal to the 1 plus the sec power 4 of 0. Sec 0 is a 1, so you get as a 2. So when x is equals to half ln 3, so this one is a bit troublesome. When x equal to the half ln 3, you need to replace this value into the sec x. So that means you will get sec half ln 3. Okay. So this one will be a bit troublesome. We need to set the sec of the half ln 3. So over here, you actually can press a calculator, but if you can press a calculator directly. Sec of half ln 3, you can get it as a 1 over cos of half ln 3. 1 over cos of half ln 3, direct press from calculator, you will get this one as the over here, it will be a bit troublesome. Okay, so this one we need some time to press it out. Unless your calculator can give you the exact value. If no, then it will be a problem for us. Okay, so this one we need to set it carefully. It will be 2 over the e to the power of ln 3 plus the e to the power of negative ln 3. So this will be 2 over 3 plus the 1 over 3. Then you combine them together, you will be able to get this as the, okay, I need more space. So this one needs some time to settle it. So if we join together, multiply everyone by 3. So you will get 2 3 divided by 3 plus 1. So you will get this one as the 3 over 2. Okay. So that means, still haven't finished yet. That means the u will equal to the square root of 1 plus the 3 over 2 power 4. And now you press a calculator, you will get this answer as the 25 over 16. It will be 5 over 4. Okay, now we only set that. Okay. So now we are ready. S equals to the 2 pi of the 0 to the half ln 3 tanh x square root over 1 plus the sec power 4x dx. The 2 pi just copy down. This value you need to make it become 2. This value you will need to make it become 5 over 4. The tanh x and the dx, the tanh x and the dx will be a negative u over u square minus 1 du. Okay, so this will become a negative u over the u square minus 1 du. And as for this part, it's a u. Okay. So there's a negative here. You can see that if the negative is gone, then the 2 value over here need to be swapped. You will get Z2 above, 5/4 below. So you will get this one as a positive u square over the u square minus 1 du. Just like that. Okay. Okay. So this is because of the integrate AB of negative fx is equal to the integrate the BA of fx because of this property. So the negative over here, it becomes positive. Okay. So over here shown, then we just say shown. Just like that, done. So this will be the answer for the number 8C part 1. Okay. Now we move on to the 8C part 2. Find the exact value for this one. Oh, sorry, I missed out a half here. There's a mistake over here. There's a half over here. And there's a half over here. And this half and the 2 here will be cancelled. Okay, so the half and the 2 here cancel. At the end, you have only pi, no 2 pi. My apologies. Okay, so this is the answer for the number 8C part 1. Now we move on to the C part 2. Okay, so now we want to find this value. You need to simplify. You need not simplify your answer. So means we just need to integrate them. Okay, so what should we do now is actually we can just integrate 5/4 square root 2 u square and u square minus 1 du. So you can see that this is an improper fractions. We need to make it become proper first. You can use long divisions, or we can use an easier way. Make it become u square minus 1 plus 1 over the u square minus 1. du. So I will be able to make this become 5/4 square root 2 and 1 plus 1 over u square minus 1 du. So over here, I need to use partial fractions. Make it become a over the u plus 1 plus b over the u minus 1. So you get 1 is equal to the a of u minus 1 plus b over u plus 1. When the u equal to 1, you have the b is equal to half. When the u is equal to -1, you have a is equal to the -half. So therefore, you will need to change this expressions, expand it to become minus the half of the u plus 1 plus the half of the u minus 1 du. So just integrate them one by one. You will get this one as a u minus a half ln of the u plus 1 plus the half of the ln of the u minus 1 from 5/4 to square root of 2. So just need to replace the value inside. Okay, just replace the value inside. You will get this one as the, maybe we need to combine them together, become this u minus 1 over the u plus 1. It will look better. So you will have this as the Z2 plus the half of the ln of Z2 minus 1 over Z2 plus 1. Then minus the 5/4 minus the half ln of the 5 over 4 minus 1. And 5 over 4 plus 1. So still have a few steps to go. This one, you need to simplify it to become ln of the 2 plus 1 minus 2 sub 2 over the 2 minus 1. Rationalize the denominator. So this one you can simplify it, become 5 minus 4 is 1. And then 5 plus 4 is a 9. You can make it like this. And simplify further again. I think this will be the last one already. You can give the answer as half ln of 3 minus 2 sub 2 minus a 5 over 4 minus plus the half ln 9. So you can have something like that. And if you want, you can actually combine these two together, provided if you want, because the question not require you to simplify the answer. So, but that is based on your own intention, based on your own will. So over here, you will have 27 minus 18 sub 2 minus a 5 over 4. Done. This will be the answer for the question number 8C part 2. And this will be the last question for this paper. So I will stop the video here. I'll see you next time. Bye-bye.